Hello everyone, welcome back to the channel. In today's video, we're diving into one of Python's most frequently asked interview topics, Lambda functions. Lambda functions, also known as anonymous functions, are small, concise functions that can be created in just one line of code. They are often used for simple tasks that don't require a full function definition and are commonly tested in interviews to assess how well you can simplify and optimize your code. We'll explore practical examples and scenarios where Lambda functions shine, giving you a solid understanding of when and how to use them effectively. Definition: Lambda functions in Python, also called anonymous functions, are small one-liner functions that you can create quickly using the Lambda keyword. Unlike regular functions, which are defined using def and given a name, Lambda functions don't need a name and can be written in a single line. They're handy for simple short operations when defining a full function would feel excessive. You will often see them used with functions like map, filter, and sorted, where you need to pass a quick operation as an argument. Lambda functions are limited to a single expression, and whatever that expression evaluates to is automatically returned, so there's no need for a return statement. This makes them perfect for writing cleaner and more concise code in specific cases. The syntax for a lambda function is simple and concise. It begins with the lambda keyword followed by the arguments the function will take, a colon, and then the expression that the function evaluates. The result of that expression is automatically returned. This all happens in one line, making lambda functions ideal for short tasks where defining a full function using def isn't necessary. Now that we've covered the basics of what lambda functions are and how they work, let's dive into some practical examples to see them in action. We'll explore how lambda functions can be used for quick one-liner operations, especially when working with higher order functions like map, filter, and sorted. These examples will show just how useful and efficient lambda functions can be for simplifying your code in specific scenarios. Let's get started. 1. Basic lambda function. Question: create a lambda function that takes two arguments and returns their sum. This example demonstrates the use of a lambda function to perform a simple addition of two numbers. The lambda function is defined with the expression lambda x y x plus y, where x and y are the parameters and the expression x plus y is the operation to be performed. Unlike regular functions defined with def, lambda functions are anonymous and defined in a single line. In this case, the lambda function is assigned to the variable add, making it reusable under that name. When you call add5, 3, the values 5 and 3 are passed as arguments for x and y respectively, and the expression x plus y is evaluated. The result of this operation 8 is automatically returned by the lambda function. Finally, the result is printed using the print result statement, displaying 8 as the output. This example highlights how lambda functions can be used for simple tasks like adding two numbers without the need to define a full function, making the code more concise and easy to read. Alright, now that we've seen how this works, let's dive into the next practical example. This one will take things a step further, so get ready to explore another useful concept. 2. Lambda with map function. Question: write a lambda function that squares each element in a list using the map function. In this example, lambda function is used in combination with Python's map function to square each element in a list of numbers. The list numbers contains 1, 2, 3, 4, 5, and the goal is to apply a mathematical operation to each element in the list. The map function takes two arguments, a function and an iterable, in this case, the list numbers. Instead of defining a full function with def, a lambda function is used to simplify the operation. The lambda function lambda x raised to the power of 2, takes each element x from the list and returns its square by evaluating x raised to the power of 2. The map function applies this lambda function to each element of the list, producing an iterator with the squared values. The list function is then used to convert this iterator into a list. The result is stored in the variable squared, which contains the squared numbers 1, 4, 9, 16, 25. Finally, the result is printed, showing the output 1, 4, 9, 16, 25. This example demonstrates how lambda functions can be used for quick one-line operations and how they integrate smoothly with functions like map to apply transformations to entire lists efficiently. 3. Lambda with filter function. Question: write a lambda function that filters out even numbers from a list using the filter function. In this example, a lambda function is used with Python's filter function to extract only the odd numbers from a list of numbers. The list numbers contains 1, 2, 3, 4, 5, 6, and the goal is to filter out the even numbers and keep only the odd ones. The filter function takes two arguments, a function and an interval, in this case, the list numbers. The lambda function lambda x divided by 2 is not equal to 0 is used to define the condition for filtering. It checks if each element x in the list is odd by evaluating whether the remainder of x divided by 2 is not equal to 0x% 0. If the condition is true, the element is kept in the resulting list, otherwise it is filtered out. The filter function applies this lambda expression to each element in the list, returning an iterator that contains only the odd numbers. The list function is then used to convert this iterator into a list, resulting in 1, 3, 5, which is stored in the variable odds. Finally, the result is printed, showing the output 1, 3, 5. This example highlights how lambda functions can be used in combination with filter to perform quick filtering operations based on a specific condition, making the code more efficient and concise. 4. Lambda with reduce function. Question: write a lambda function that multiplies all elements in a list using the reduce function from functools. In this example, a lambda function is used in combination with Python's reduce function from the functools module to multiply all elements in a list of numbers. The list numbers contains 1, 2, 3, 4, and the goal is to compute the product of all the elements in the list. The reduce function takes two arguments, a function and an iterable, in this case the list numbers. The lambda function lambda xy, x multiplied by y, is used to define the operation to be applied between pairs of elements. It takes two arguments x and y and returns their product x multiplied by y. The reduce function applies this lambda function cumulatively to the elements in the list, starting with the first two elements and then applying the result to the next element, and so on until all elements are combined. For the given list 1, 2, 3, 4, the lambda function multiplies the elements as follows. First one multiplied by 2 to get 2, then 2 multiplied by 3 to get 6, and finally 6 multiplied by 4 to get 24. The final result, 24, is stored in the variable product. The result is printed, showing the output 24. This example demonstrates how lambda functions, when combined with reduce, can be used to perform cumulative operations like multiplication, addition, or any other associative operation on a sequence of values in an efficient and concise manner. 5. Sorting with lambda. Question: use a lambda function to sort a list of tuples based on the second element of each tuple. In this example, a lambda function is used in combination with Python's sorted function to sort a list of tuples based on the second element in each tuple. The list data contains the tuples 1, 4, 3, 1, 5, 2, 7, 0, and the goal is to reorder the tuples in ascending order based on their second elements. The sorted function takes two arguments, the iterable to be sorted, in this case the list data, then the key parameter, which is used to specify the basis on which to sort the key. Here, the lambda function lambda x1 is passed to the key parameter. This lambda function takes a tuple x as input and returns the second element x1 of the tuple. The sorted function then uses this value as the sorting key, rearranging the tuples based on the second element. In the list data, the second elements of the tuples are 4, 1, 2, 0. The sorted function sorts these values in ascending order, resulting in the tuples being reordered as 7, 0, 3, 1, 5, 2, 1, 4. The result is printed, showing the output 7, 0, 3, 1, 5, 2, 1, 4. This example demonstrates how lambda functions can be effectively used with the sorted function to customize sorting behavior based on specific elements within complex data structures like tuples or lists. 6. Conditional logic with lambda. Question: write a lambda function that returns the larger of two numbers. In this example, a lambda function is used to determine the larger of two numbers. The lambda function is defined as lambdas y, x if x greater than else y, which takes two arguments x and y. It uses a conditional expression or a shorthand if else statement to compare the two numbers. If x is greater than y, the lambda function returns x, otherwise it returns I. The lambda function is assigned to the variable larger, making it easy to reuse. When the lambda function is called with the arguments 10 and 15, it compares the two numbers. Since 15 is greater than 10, the lambda function returns 15, which is then stored in the variable result. Finally, the result is printed showing the output 15. This example demonstrates how lambda functions can be used for quick comparisons or conditional logic in a concise one-liner format, making the code simpler and more efficient for basic tasks like finding the larger of two values. 7. Lambda is sorted for complex sorting. Question: use a lambda function to sort a list of dictionaries by the value of a specific key. In this example, a lambda function is used with Python's sorted function to sort a list of dictionaries based on age key. The list people contains dictionaries where each dictionary represents a person with two key value pairs, name and age. The goal is to sort these dictionaries by the age field in ascending order. The sorted function takes two arguments, the iterable in this case, the list people, and the key parameter which is used to specify the value that should be used for sorting. Here the lambda function lambda person age is passed to the key parameter. This lambda function takes a dictionary person as input and returns the value associated with the age key. The sorted function then uses this value to order the dictionaries. The result is a new list sorted underscore people where the dictionaries are ordered by age: Jane, who is 22, John, who is 25, and Do, who is 35. When printed, the output is name Jane, age 22, name John, age 25, name Do, age 30. 8. Sorting complex nested data with lambda functions. Question: write a Python program to sort a list of employees based on two criteria, their department level and nested field, and their salary. The employee data is stored in a list of dictionaries where each dictionary contains employee details such as name, salary, and department, and the department itself is a nested dictionary. This example illustrates how lambda functions can be effectively used with sorted to sort more complex data structures like lists of dictionaries, allowing you to easily customize the sorting behavior based on specific fields or values. In this more complex example, a lambda function is used to sort a list of dictionaries that contain nested dictionaries. Each dictionary represents an employee with information about their name, salary, and department. The department itself is represented as a nested dictionary with additional information, such as department's name and level. The goal here is to sort the employees first by their department level and then by their salary. This is achieved using the sorted function with a lambda function as the sorting key. The lambda function lambda emp department level emp salary specifies a tuple as the sorting key. The first element in the tuple emp department level sorts the employees by their department level in ascending order. If two employees have the same department level, the second sorting criterion emp salary is used to sort them by salary. The result is a list of employees sorted first by their department level and, for those in the same department level, by their salary. This example shows how lambda functions can handle more complex sorting operations involving nested data and multiple sorting criteria. It demonstrates how flexible and powerful lambda functions can be when dealing with structured data, allowing you to customize sorting in intricate ASTO. 9. Grouping and sorting students by section and grade using lambda functions. Question: write a Python program that sorts a list of students first by their class section alphabetically and then by their grades in descending order within each section. The student data is stored in a list of dictionaries with each dictionary containing the student's name, grade, and section. In this example, a lambda function is used to sort a list of students based on two criteria, their class section and their grade in descending order within each sending. Each student is represented as a dictionary with three key value pairs, their name, grade, and section. The sorting is performed using the sorted function, where the lambda function lambda student section student grade is passed to the key parameter. This lambda function sorts the students first by their section alphabetically and then by their grade descending order within each section. The student grade part ensures that students with higher grades appear first within each section. For example, in section A, Charlie with a grade of 90 will appear before Alice with a grade of 85 and Eve with a grade of 70. In section B, David with a grade of 95 will appear before Frank with a grade of 80 and Bob with a grade of 75. The result is a sorted list of students grouped by their class section, with students in each section ordered by their grades in descending order. This example shows how lambda functions can be used to handle group sorting with multiple criteria efficiently. 10. Combining map filter and reduce with lambda functions in Python. Question: write a Python program that combines the operations of map, filter, and reduce using lambda functions. The program should first filter out numbers greater than 10 from a list, then double the filtered numbers, and finally sum the doubled numbers, all within a single lambda function workflow. In this example, we use filter, map, and reduce together with lambda functions to perform a series of transformations on a list of numbers. The list numbers contains 2, 5, 8, 10, 15, 18, 20, 25, and the goal is to filter the numbers greater than 10, double the filtered numbers, and then sum them all. Filter: we start by using the filter function with the lambda function lambda x greater than 10 to filter out numbers that are greater than 10. This results in the filtered list 15, 18, 20, 20. Map: next, we use the map function with the lambda function lambda x multiplied by 2 to double each number in the filtered list. This results in the mapped list 30, 36, 40, 50. Reduce: finally, we use the reduce function with the lambda function lambda x plus y to sum the double numbers. The reduce function combines the elements from the mapped list step by step, resulting in the sum of 30, 36, 40, 50, 151. The result of this entire operation is printed as 186. This example shows how map, filter, and reduce can work together with lambda functions to perform efficient and readable transformations on a list of data, applying filtering, mapping, and reduction all in one workflow. That wraps up our exploration of lambda functions and the practical interview questions you might encounter. As you've seen, lambda functions are a powerful tool for writing quick, concise code, especially when combined with functions like map, filter, and sorted. Make sure to practice these examples so you're well prepared for your next interview. If you found this video helpful, don't forget to like, share, and subscribe for more Python interview prep and coding tips. Thanks for watching, and I'll see you in the next video.